All right, we're going to solve sine x plus 1 equals 0 and then only give 4 solutions. So keep in mind, our goal was always to isolate the trig function and then do your little triangles or your inverse button on your calculator to get all the solutions. So we could get all the solutions and then boil it down to just keeping 4 of them. So I'm going to isolate the trig function first. Now, since it's a -1, I'm thinking quadrantals and unit circle, and we know sine is the y value on the unit circle, so it looks like to be -1 down here, which means I'm looking at the angle. If I want to go in the positive sense, I guess 3 pi over 2, or if you want to go in the negative sense, that would be -pi over 2. And so I could do x equals, I guess, 3 pi over 2 plus 2k pi, since the sine function has period 2 pi. But since it says only give 4 solutions, I just need to worry about giving 4 of them. So I'll let like k be equal to 0, maybe k be equal to 1, k equal 2, k equals 3. Or you could even let them be negative numbers. It doesn't matter, whatever integer you want to choose. So if I do that and plug it in all the k's each time, I'm going to get my 4 solutions. So the first one is just going to be that, because k is 0, so forget that. Then I have 3 pi over 2 plus k is 1, so just 2 pi. Get a common denominator, I guess that's 7 pi over 2 if I add the 4 pi over 2 to it. Then we're going to let k be 2. So 2 times 2 is now 4 pi. Common denominator, that's 8 and 3, I guess 11 pi over 2 is my next answer. And then I guess I can even pick up another one and say, hey, -pi over 2 will work, or put k equals 3. If k is 3, 2 times k is 2 times 3, which is 6. So I have 6 pi now that I'm adding. And that's going to give me a 12 pi plus the 3, I guess 15 pi over 2 is my next answer. So ultimately all I did was start at 3 pi over 2 and then just keep circling 2 pi's. That's how the 2k pi visually, as you can see, picks up all the answers, because you keep going around and around and around and picking the different solutions. So they wanted 4 solutions. We got the 4 solutions. We started off getting all the solutions. And then we said, okay, from all solutions, we'll boil it down to just picking 4 of them. And you could let k be whatever you want. You could let k be 1,000 and give me a solution way, way down the road. Part B, same idea. Our goal always is to isolate the trig function. So I'm going to isolate the trig function and then see what we can do. We'll divide both sides by 4. That's cosine theta equals -1/4. And it looks like negative is going to be in quadrants 2 and 3 for the cosine function, because it's the x value, and x is negative here and here. So basically I have this answer that I need to get with a cos inverse button on my calculator, and then maybe this answer that I need to get. So let's go at least get the first one in red from our TI. So I'm going to do second cosine, that's cos inverse -1 divided by 4. That guy is giving me 1.82, let's say. So there's one of them, 1.82. To go all the way around. So I'm going to get all the answers for practice, and then we're going to only keep 4 of them. So theta is 1.82 plus the period of cosine, all multiples of it, plus 2k pi. So if I wanted to, as of right now, I could let k be 0, 1, 2, 3 and be done with it, right? Because then I would have my 4 solutions. But I'm going to practice and also go get the blue angle, just so you visually see what the blue angle is. I mean, if I go in the negative sense, like if I go like this, right? That's going to be -0.82. I mean, I could even use that, right? And we could just say, well, the other guy is -1.82. I'm going in the other direction, plus 2k pi. why not that? Or if you want to think of it as what's the positive blue, so all the different ways you can come up with it. If you want to think of it like that, then there is this little leftover piece that it will be the same as this little leftover piece, which means you would be adding it to pi. So another way you can think of it is to get this little leftover piece, I've gone all the way pi, but that little piece has to remain, so pi minus like 1.82 would give me the little leftover piece. Pi minus, let's do second answer, just to grab this answer that I already had from before, 1.32. So that's 1.32, which means this little image also is 1.32. So if I want the blue answer, then for my blue, I'm going all the way to pi in that upper part, and then a little bit past it, which is 1.32. So pi plus 1.32 is another way you can think of that blue angle. All the different possibilities, because they're all coterminal. So pi plus, I'll do second answer to pull up the previous answer. 4.46, I guess, is another way I can think of it. So all the different possibilities for your answer you can give, like for this guy, if you wanted to use a positive angle, you could use 4.46, but your choice. It doesn't matter which way you go about it. Once you have all your solutions, getting 4 solutions is no big deal, because you'll just let k be different values. So let's say for this guy, I want to pick up 2 from here. Say I want k equals 0 and k equals 1. Well, if k is equal to 0, my first one is 1.82, and then I also have 1.82 plus the 2 pi. All right, so we got 2 of those. And then this guy is negative for tangent, so it's going to be in quadrants 2 and 4 that we're dealing with. So quadrant 2, quadrant 4. Tangent is opposite over adjacent. If I'm standing here facing this guy, and if I'm standing here facing the other guy, is opposite over adjacent. So again, we got the special triangle with the reference angle of 30 degrees. So one angle is stopping 30 degrees short of 180. I guess that's 150 degrees. And then the other angle is stopping 30 degrees short of 360 degrees. So I guess that's 330 degrees. Or if we're doing it in radians, instead of 6 pi over 6 going all the way, we stop one short, 5 pi over 6. And instead of going all the way to 12 pi over 6, we stop one short at 11 pi over 6 if we need it in radians. And since they only wanted 4 solutions, I guess that's good enough. And if you wanted to do it with k's for all solutions, you could pick the first one and add pi k to add all the other ones, or to pick up all the other ones. And you could also pick this 150 degrees or 5 pi over 6 and then add pi k to pick all the other ones. Then let k be equal to 0, 1, 2, 3, whatever you want to have your 4 solutions. But since they wanted 4 solutions and we saw 4 triangles right off the bat, might as well just use those as our 4 answers. And that's it for example 3.